Hello everyone, and welcome to today's chem lesson. Today we are going to wrap up our talk of the atom by looking at something that I promised we would come back to a couple of different times. Today we're going to look at ions, which is an atom that has either gained or lost electrons. Now, we spoke about the different numbers that you see on the periodic table. We talked about the different numbers that you see on this abbreviated form of element identification. Right, these numbers here, right? This 10 in the bottom left, this 18 in the upper left, and this 0 in the upper right. When we looked at these in the past, we defined each one of them, right? This is the atomic number, which is the number of protons. This up here is the mass number, which is protons plus neutrons. And then this final number over here, which has been 0 every time we've looked at it, is the charge, which is the number of protons minus electrons. And we have left this number at 0 since we learned about this. But today, when we talk about ions, we're going to talk about times when this number isn't 0. We know that atoms are neutral by default, right, with a number of protons and electrons that are equal. So we have 10 protons and 10 electrons in this example. Right, 10 positives and 10 negatives to give you a total charge of 0, right? The 10 positives and the 10 negatives cancel each other out. But there are a bunch of different ways that atoms can gain or lose electrons, which turns them into ions, right? Anytime you have an atom that has gained electrons, it's an ion. An atom that has lost electrons, that's an ion. So anytime you see an atom with a charge, you are looking at an ion. Now, remember that electrons are negative. So if I say that I have gained electrons, right, if we have a different setup, if I want to show protons 10 because they have to be, but if I want to show something that has lost electrons, and I want to say it has 8 electrons now, I have 10 positives and 8 negatives. My total charge is actually going to be positive 2. I have lost 2 negatives, so my balance swing towards the positive. If I end up with 15 electrons, my total charge is going to be a negative 5. Because I have gained 5 more negatives. Now my negatives outnumber my positives by 5. It's a little bit counterintuitive at first. A lot of people think I gained electrons, so I should have a positive charge because I got something. But that's not the way it works. You have to condition yourself and train yourself to realize that electrons are negative. So if you got more negatives, you became more negative. If you lost negatives, you became more positive. So, an atom that has lost 3 electrons has a charge of A, positive 3, or B, negative 3. correct answer here is choice A. Losing electrons, getting rid of negatives, means that you have a more positive substance, right? You now have a positive ion. What about gaining 4 electrons? What charge is gaining 4 electrons going to give us? Here, the correct answer is choice B. Gaining electrons, gaining negatives, is going to make that atom into a negative ion. The next thing I want to talk to you about is the reason why atoms would gain or lose electrons anyway, right? What's the point? And the point is to make these substances stable. When we look at the shell model of the atom, we have the electron shells, which is every shell of the atom, but we also have what's called the valence shell, which is the last shell. No matter how many electrons are in it, the valence shell is always the outermost shell. And the valence shell of every atom is going to determine the way it behaves. It's a huge part of why the periodic table is arranged the way it is. It's a huge part of reactions and why we have certain compounds and not others. The valence shell, however you want to pronounce that A, is the shell that contains the outermost electrons. And for reasons related back to the quantum mechanical model, atoms will do their best to get a valence shell that has 8 electrons in it or 0 electrons in it. They will try to fill their valence shell to 8 or empty it to 0. The only exception here is helium and hydrogen because they only have the first shell, which can't hold 8, it can only hold 2. But every other substance is going to try to fill their shells to 8 or 0. For some atoms, it's easier to gain electrons, right? If you have 7 electrons, it's easier to gain 1 than get rid of 7. For others, it's easier to lose. If you have 2 or 3 electrons, it's easier to get rid of 2 or 3 than to gain 5 or 6. And so we're going to do an example. We're going to look at sodium and chlorine. Sodium is element number 11, and chlorine is element number 17. We're going to draw them both without charge right now. Right? Neutral copies of these atoms. If the charge is a 0, I know the number of electrons is going to be equal to the number of protons down here in the bottom left. And so when I put together this shell model, I have 11 electrons to put. 2, 8, 1. fill the first, fill the second, put the rest in the third. For chlorine, I have 2, 8, and 7. Fill the first, fill the second, put the rest in the third. Sodium has 1 valence electron, and chlorine has 7 valence electrons. In order to get to 8 or 0, it has 2 choices. Sodium can gain 7 electrons to get to 8, or it can lose 1 electron to get to 0. Atoms will always take the easier path. It will always do the thing that has a lower number. So if we're looking at the choice between gaining 7 or losing 1 electron, sodium is going to lose 1 electron. And when we want to then draw that sodium ion, instead of 281, we are now going to have 280, or just 28. And now our sodium, which has lost 1 electron, is going to have a charge of positive 1. This ion is now positively charged. And it did what it wanted. It now has 0 valence electrons, which is great. That's what every atom wants. They want to get to 0 or 8. Let's take this whole process over to chlorine. Chlorine has 7 valence electrons. And so it has 2 options. It can gain 1 electron to get to 8 valence, or it can lose 7 electrons to get to 0 valence. Gaining versus losing isn't the important thing. The important thing is looking at the amount of electrons that would have to be gained or lost. Gaining 1 is easier than losing 7, and so chlorine is going to gain 1 electron. And when we look at the resulting ion that is formed, we have a negatively charged ion because it gained electrons. It's -1 because it gained 1 electron. And it has 8 valence. 8 electrons in its outer shell, which is what it wants. And yes, so we're going to take whichever option requires less electrons. So gaining versus losing isn't important, it's the value of this number here. We want to take the smaller number. So if you have a choice between gaining 3 or losing 5, you're going to gain 3, because 3 is smaller than 5. Here, 1 is smaller than 7, so we're going to take the 1 in both of these cases. Now the question becomes, what happens to this lost electron? Sodium had 11 electrons, got rid of one, but sodium can't just pull out an electron and throw it into the ether. So sodium must have given this electron to another atom. Huh. Chlorine gained an electron. Where did chlorine get this electron from? It's not a street magician who can pull an electron out of thin air. Poof, here's an electron. It had to take it from a different atom. Sodium and chlorine, those come together in a way that we know. Right? Those come together as NaCl to form a compound, don't they? They make salt. Do you see how this partnership takes a sodium with not the right number of valence electrons and a chlorine with not the right number of valence electrons and allows them to interact in a way that makes both of them get what they want? Sodium loses its valence electron, and who happens to pick it up? Chlorine does. This partnership that they have makes them both stable. It satisfies this 0 or 8 valence electron rule. And as we move forward and start talking about compounds and start looking more in depth at the way atoms are going to act, we're going to see that this need to get 0 or 8 valence electrons really drives a lot of the properties of these atoms. Chlorine acts the way it does because it needs to gain 1 electron. Sodium acts the way it does because it needs to lose 1 electron. And as we move forward and get into our next unit about the periodic table and the patterns and the trends that we see, we will see this at the root of it all. The idea that filling or emptying a valence shell is the most important thing to an atom, the most important thing to the stability of an atom. And I'm going to transition us over to our Zoom meeting now for questions, comments, concerns, and attendance. I'll see you there.